We are actually ready to begin learning about logarithms now. Chapter 10, Section 4, we get the definition of logarithms, and we're addressing State Standard number 11, subsection 1. Students need to understand the inverse relationship between exponents and logarithms, and be able to use this relationship to solve problems that involve logarithms and exponents. So our objectives, we need to define logarithmic functions in today's lesson, and then we need to learn how they're related to exponential functions. Here's our definition of a logarithm. If lowercase b and uppercase n are both positive numbers and b is not 1, then the log of n base b equals k if and only if b to the k power equals n. That's our definition of a log. So we're going to take this exponential equation and rewrite it in this form, and they're equivalent. And here's how we're rewriting them. So we need to be careful. The log of the number, that's the number that's by itself in the exponential one. In the exponential form, b, the base, is the base. So we have the log of n base b. This is the base b to the k power. So the base stays the base. The number is the number by itself in the exponent, and k is the exponent. If you recall from some previous lessons that I said, remember, when all else fails, a logarithm is an exponent. So the exponent k, b to the k power equals n, k is, because we can replace the word equal sign with the word is, k is the log of n base b. The log is the exponent. You need to know how to rewrite in both formats, from log to exponent, from exponent to log format, without hesitation, without taking very long to do it at all. Got to get it memorized, got to get it quickly. In addition, we've got some properties of logarithms you need to know. Two logs of the same base can only be equal if the logs of the numbers we are taking them of are equal to each other. So log of m base b is equal to log of n base b if and only if m and n represent the exact same number. If you have the log of a number raised to a power and the base is the same base as this power, these bases pretty much cancel each other out, and we're just left with the exponent k. Here's another one. If you got a base b, and your exponent is not just a number, but a logarithm, log of n base b has to be the same base. Then this base and this log with the same base pretty much cancel each other out, and you're just left with n. The log of any number to that same base is 1. And the log of 1 to any base is 0. So these are some properties of logarithms you must memorize, and you will understand them a little bit more clearly as we do some numeric examples. So let's move ahead to these numeric examples. Let's look at some things in exponential form. Let's look at them in logarithmic form. So if I've got 2 to the third power equals 8, 2 to the fourth power equals 16, 2 to the 0 power equals 1, all true statements. If I have log of 1/2 base 2 equals -1, and log of n base 2 equals k, let's try rewriting these first three in logarithmic form and these last two in exponential form. We need to practice. So remember, the exponent 3 is the log of this number, and this is the base 2. So 2 to the third power equals 8. In logarithmic form is written as the log of 8 base 2 is equal to 3. Just remember, the exponent is the log. The base stays the base. Alright, so the next one ought to be pretty easy then. 4 is the exponent. So the exponent is the log of the number 16 and its base 2. So if you can take the exponent and the bases and locate them, by process of elimination, you know what to do with the numbers. 2 to the 0 power equals 1 translates into the exponent 0 is the log of this number 1 and its base 2. And in the other direction, this number is the log. Well, an exponent is the log. Here's the base, the log of 1/2 base 2. So it's going to be 2 the base to the exponent -1 is equal to the 1/2 power. Likewise, 2 is the base here. This is the exponent, so 2 to the k power equals n. Alright, so we're going to practice rewriting some more of those. We've seen a few, but it's important you learn how to do them. If you can't solve it as a log, try rewriting as an exponent. And remember, if you can't solve it as an exponent, try rewriting it as a log. But in this case, there's nothing to solve. It's a true statement. Log of 36 base 6 equals 2. To rewrite that, the base is 6, 2 is the exponent. So this is saying 6 to the second power equals 36. True statement. This is going to say 2 to the first power equals 2. A true statement. This one's going to say 10 to the -3rd power is 1/1000th. Because we have our tens, hundreds, 1000s placed. So 1 over 10 cubed is 1 over 1000. So again, we're practicing rewriting logs as exponents. Now we're going to rewrite exponents as logs. And you have to be very good at this. Do them quickly without hesitation. So the exponent 0, this is the base, so equals the log of 1 base 6. Another true statement. Here's another exponent. Rewrite it as a log. Well, the exponent is the log. So -2/3 is the log. 8 is the base. 1/4 is the number. Alright, 5 to the 3/2 power is the same as 5 times the square root of 5. Another true statement. So just to rewrite it, the exponent 3/2 is the log of this number 5 square root of 5, and the base is 5. Alright, so all we're doing is rearranging the furniture, rewriting logarithmic notation in exponential notation, and exponential notation in logarithmic notation. Now we need to start getting down to the business of simplifying and solving. And I hope you get so good at this that you can say right in your head, as soon as you see this problem, the answer is 2. If you're not sure though, say, well, I don't know what that's equal, so let it equal x, a variable. And we will take this log, which you may not know how to solve, and we're going to rewrite it as an exponent and see if it's easier to solve. 5 is the base, x is the exponent, equals 25. And of course, 25 is the same as 5 squared. And the only way that these two quantities can be equal, that have the same bases, is if the exponents are also equal, so x must be 2. So remember, a log is looking for an exponent. That's the long version. We should be able to do this much more quickly and ask this question. 5 to what power is 25? A log is looking for an exponent. 5 to what power is 25? The answer to that is 2. We can do that in our head. This is saying 2 to what power is 8 square roots of 2? So we don't know just yet. Let's just say that equals to x. Let's rewrite it in exponential form. The base 2 to the x power is equal to 8 square roots of 2. 8, let's write that as 2 cubed. And we've already learned that the square root of 2 is the same as 2 to the 1/2 power. Remember, with rational exponents, the base is the radicand, the denominator is the root index, and the numerator is the power we're raising that to. And when we're multiplying and the bases are the same, we keep the base and add the exponents. 3 plus 1/2 is 3 1/2, or we can call it 7/2. And the only way these two can be equal, if the bases are the same, the exponents must also be the same. X must equal 7/2 or 3 1/2, whatever you prefer to call that. Alright, 2. What's 2 to the log of 7 base 2 power? Well, the answer to that is 7, because we memorized, or at least I showed you, the properties of logs we need to learn. If we don't recognize that, we'll say, well, I don't know what it's equal to, so let it be equal to x. Even though there's a word log here, it's in the exponent. So this is the exponential form. Let's rewrite it in the logarithmic form. My exponent is the log of this number x base 2. Now, the only way these two quantities can be equal if they're both logarithms base 2 is if these numbers are the same, and that's another property of logarithms that we looked at the beginning of this lecture. So x must equal 7. Alright, let's solve some things. We've got variables in here. The log of some mystery number x base 4 is 3. Maybe we can't solve it as a logarithm. So the key to this chapter is if you can't solve it as a log, rewrite it as an exponent. If you can't solve it as an exponent, rewrite it as a log. So this is the base 4 to the third power equals x. And now this is very simple to solve. 4 cubed is 64. So the log of 64 base 4 is 3. Alright, next example, the log of 81 base x is equal to 4. Rewrite that as an exponent. X, the base, to the fourth power is 81. Don't know what x is, but if I take the fourth root of both sides of this equation, on the left side I'll get x, and of course you've memorized your perfect squares, perfect cubes, perfect fourths. The fourth root of 81 is 3. So again, you can't solve it as a log, rewrite it as an exponent. If you can't solve it as an exponent, rewrite it as a log. So let's look at example 5a. We've got the log of 2 to the fifth power base 2. Now in your head you should be able to say 5. It's the answer as we get good at this. Maybe not immediately. But we're saying 2 to what power is 2 to the fifth power? So let's say, well, we don't know what it is. Let it equal to x. Let's rewrite it as a log, as this log, which we don't know how to solve, perhaps. Let's rewrite it as an exponent. So 2, the base, to the x power is equal to 2 to the fifth power. Again, the only way these quantities can be equal when the bases are the same is if the exponents are the same, so x must equal 5. Alright, what's the log of 2 base 2? Well, this is also one of the properties of logs we learned at the beginning of this lecture. Answer is 1 because we're saying 2 to what power is 2? And if you can't visualize that in your head, let's say, well, we don't know what it equals. It equals x. And we don't know how to solve logs, so let's rewrite it as an exponent. 2 to the x power is equal to 2. And that's to the first power. The only way these can be equal is if the bases are the same and the exponents are the same, therefore x must equal 1. And let's look at this one, the log of 1 base 2. Now the answer is 0. You may not see that right away, but we're saying 2 to what power is 1? So if we don't know that, let's just say that equals x. And let's just say, well, we don't know how to solve logs, so let's rewrite it as an exponent. The base 2 to the x power equals 1. And we know we could write 1 as 2 to the 0 power, because anything except 0 itself to the 0 power is the same as 1. And again, the only way these two quantities can be equal if the bases are the same, the exponents must be the same, so x must be equal to 0. And that's our first look at definition of a logarithm and rewriting logarithmic form in exponential form and vice versa.